Hi there, we're going to be revising a whole bunch of things in this video. We're going to be looking at number patterns, integers, and operations. So let's get straight into it. So the difference between composite and prime numbers. A composite number is a number that has more than one factor. A factor is when you times two numbers by itself, it becomes that number. So as an example, if I look at what are the factors of, let's say, 12. Okay, so we have 1 times 12 equals 12. We have 2 times 6 equals 12. And we have 3 times 4 equals 12. So the factors of 12 are 1, 2, 3, 4, 6, 12. They all can be times by something to equal 12. So that's the factors of 12. So we call it composite because it has more than one times itself as a factor. A prime number is the opposite, where it only can be times by one in itself to have it. So an example of a prime number is 11. There's no numbers I can times by to get to 11. It's just 1 times 11 equals 11. There's no other times tables that you could do unless you were going to use decimals or fractions, and yeah, that's not what we're looking at. We're looking at whole numbers, so that's what a prime number is. So best way to check if it's a prime number is just try and write all its factors, and if you can't think of any, then it will be a prime number. Square numbers. So square numbers, funny or not, they look like a square when you draw them. So right here I've actually drawn the square number of 9 right here because I've got 3 times 3. Yeah, I've gone 3 this way and then 3 this way. So 3 times 3 equals 9. So 9 is a square number because if I did it visually, it looks like a square. I've done it in dots here. I suppose a few tricks of working out what a square number is, like if the question said, is 49 a square number? One way to do it is just to do trial and error and go, well, what's 5 times 5? So 5 times 5 equals 25, and that's not 49. I'll try the next one. What's 6 times 6? 6 times 6 is 36. That's not it either. And I'll just keep going until I see if a number answers 49. So remember, square numbers is a number times itself. So let's try 7 times 7, and that equals 49. Oh, wonderful. So it means that 49 is a square number because 7 times 7. I'll also write it as 7 squared. This little 2 on the top, or we have a power of, just means that it's timesing itself. So about 7 times 7. And that equals 49. Okay, that's what a square number is. So an example of something that's not a square number is 26, right? So 26, I can't times something by itself to get to 26, again, unless if it was some number with lots of decimals, and it will be very hard to do it. We actually work backwards, and you can say, well, what is the square root of 49? And the answer is 7. So square root is when you're going the opposite direction, it looks like that. Triangular numbers, again, when you draw them out, they look like triangles. So here we have 1 as a triangle number, we have a 3, and so on and so forth. So how am I getting these numbers? I'm just counting them. So I've got 1 plus 2 plus 3, yeah, because I've got 1 here, 2 here, 3 here. So 1 plus 2 is 3, 3 plus 3 is 6, the next one's 6. What's this one? So I've got 1 plus 2 plus 3 plus 4, right? So I've got 3 plus 3 is 6, or we can just remember the previous triangle, plus the bottom number. So 6 plus 4 is 10. And the next one, so I've written it in this way. So I've got 1 plus 2 plus 3 plus 4 plus 5. Once you've got the pattern, I'm just going, well, really, I could say 1 plus 2 plus 3 plus 4 plus 5, or I could just say that is just 10, because I knew the previous one, plus 1 more than what I've done. So the last one I did was plus 4, so this time I do plus 5, so it'll equal 15. What will the next triangle be? Well, I don't need to draw it, because I can just go, well, 15 plus 6, because the last time I added 5. So 15 plus 6 is 21. And if I want to know what's the next triangular number, I'll go plus 7, because that's 1 more than 6, and that equals 28. And then the next one will be just plus 8, because last one I was plus 7, and that will be 36, and so on and so forth. So really the trick to this one is just get a piece of paper and just keep going, and stop when you get to whatever the last number is in the, is this number a triangular number? There is a special formula to do it, but 9 times out of 10, that'll be the quickest way of doing it. Next part is divisibility. Divisibility is the idea that can that number be divided by something? So if I said, here's an example, 55. Can 55 be divided by 5? That's what a divisibility rule is. It's what we do to check, can it work? Will it be a whole number, or will it equal something with a decimal in it? So I don't actually need to work out the answer. I just need to say yes or no. Does it work? There's a rule for every number, really. So let's look at the rule for number 5. So I've just got this from the website Maths is Fun, so feel free to go on it yourself. It says here, the rule for 5 is the last digit is 0 or 5, then it's yes. So if I look at 55, the last digit is a 5, so it is a 5 or a 0, so yes, it works. Yeah. If the number was 27, then no, because the last number is not a 5 or a 0, so no, it's not divisible by 5. So you can go in yourself, you can just pause the video and look at the rules, or go on that website, and that will help you. So here's the rules for those, and here's the rules for 9 through to 12. I would say one of the more trickier ones is 7. So yeah, that would be the thing that's a bit tricky. But yeah, some of them I think are really fun rules. So like 3, so you add up all the numbers together and then see if that goes into 4. So I don't know, if I pick another example, is 2,354 a divisible by 3, or add them all up. So just go plus, plus, plus. So 2 plus 3 is 5, plus 5 is 10. 10 plus 4 is 14. And I say, well, is 14 divided by 3? Does it work? And I'm like, no, it doesn't. So no, it's not divisible. If the answer was 12, let's pretend, then yes, it works, because 12 divided by 3 is 4. So it works. So that's how that works. Number patterns. So here we've got a number pattern. So if I look, my trick here is I always like using little arrows. So I go, what's the difference between 4.3 and 3.97? So the number's gone down, so I'm going to subtract. So I'm going to go 4.3, take away 3.97. I've got a missing number here, so I'm going to add a 0 as what we call a placeholder. So 0 take away 7. I can't do. I've got to go next door to its neighbor. Turn that into a 2. Now it's 10 take away 7, which is 3. 2 take away 9, I can't do. So go to next door neighbor. Make it now 12 take away 9, and that should be 3 as well, shouldn't it? I hope. And then 3 take away 3 is nothing. So my first jump was, it was take away 0.33. Now let's see what's the difference between these two. The number's gone up. So I could just count and see what's the difference, because like I can see the 7's the same in the hundredths column, which is 2 places after decimal. So I just know in the tenths column it's gone up by 4. It's gone from 5 to 9. So the jump, it's gone from 9 to 5. Sorry, so I've gone 9 to the next 0, 1, 2, 3, 4. So it's gone up 5 actually. So it's actually gone plus 0.5. If you don't believe me, then we can try it this way. We can go 4.57 take away 3.97, right? I'm just doing the bigger one, take away the smaller one. and whatever the answer is the difference. So 7 take away 7, 5 take away 9, can't do, cross it out, do it again. 15 take away 9, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6. Oh, it was 6. There you go. I must have made a mistake. I think I must have made a mistake when I went to the next whole number. Must have been. So it was plus 6. And then I'll check the next one and next one. I think what I've already realized is this one's an alternating pattern. Alternate means when you do one thing, you write the answer, and then the next one you do another thing. So this another thing, I'm going to have to go take away 0.33. And then for this one, I'll go plus 0.6. And this one, I'll go take away 0.33. And then this one will be plus 0.6. And I'll write in my answers. So I'll just pause the video right now and quickly do that for you. Okay. I don't know what I've just done. There you go, fixed. So my answer was 4.24. My next one was 4.51. My next one is 5.11, or 5 and 1/10, 1/100th. There you go. For next point is what are greater than and less than. So we have these two symbols, right? What this symbol right here just means less than, and this symbol here, so this means less than, and the next one means greater than. How you remember that is you can always draw it as a crocodile or a shark or a piranha, however you want it, with sharp teeth. It always wants to eat the bigger number. So if I imagined a number like was here, 2 and 3, it's wanting to eat the bigger one. So I say 2 is less than 3. If I want to use those same numbers, but with this symbol, I'd have to write it the opposite direction. I have to go 3 on this side and 2 on this side, and say this is 3 is greater than 2. It's always wanting to eat the bigger number. So that's greater than, less than. Negative numbers, or negative integers. So I've got a number line here to help us visualize it. When we're on a number line and we're going this direction, the numbers go positive, goes higher and higher. The next one will be 5. Next one will be 6, so on and so forth. When we're going this direction, they go negative once we're past 0, right? So, so if I'm on 0, but the next one after 0 will be -1, -2, -3, -4, -5, 6, 7, 8, 9, 10, -11. So you can see on this that if I want to compare -8 and -4 as an example, you can see, well, -4 is bigger than -8 because it's it's closer this direction. Yeah, whatever's that way is a bigger number. So if I said -8 is less than -4, or I'd have to say -4 is greater than -8. So just because 4 is smaller than 8 doesn't mean that it's a smaller number. Because of this negative, you got to really picture it in this number line idea to help you understand it. To say, yes, no, -4 actually is bigger. Yeah, it's like if I said, would you prefer I take $8 from you or take $4 from you? You'd say, oh, I prefer you take $4 because I'll have more money then. If you take $8, I'll be very poor. Final question. Order of operations. So this is the idea of BODMAS. So remember, BODMAS just means I do brackets first. I do other or order numbers. So it's like things like a square number, things like that. We have D and M, both division and multiplication. They're both equally important. And then addition and subtraction are the least important, but they're both equal, right? So these two are equal, these two are equal, that one and that one. So this is first, second, third, fourth importance, right? So if you look at your question, I look, well, do I have any brackets first? I do, so I have to solve that first. So 6 take away 2 is 4. Now, do I have any more brackets? No. Do I have any square numbers? No. Do I have any multiplication or division? They're both equal. Yes, I do. I always like to do the one that's furthest to the left first. So I've got 2 times 3. I'm going to put them in brackets so I know that that's what I'm solving right now. So I've got 2 times 3 is 6. I might rewrite the question so it just is a bit more clear. So I've got 45 plus 9, take away 6, divided by 4. Okay, now what's my next thing? Well, I still have a division, so I have to do that first. So 6 divided by 4. Oh no, this is not going to work. It's going to be a weird decimal number. Anyway, I can still do it. 4 divided by 6 is 1.5, I believe, 1.5. Hopefully your questions don't have weird decimals like that. And then my last one, if I rewrite it, 45 plus 9, take away 1.5. I've just got addition and subtraction left. They're both equal importance. I'm going to do the one furthest left just because that'll be easier. So 45 plus 9 is 54. And then 54 take away 1.5 is my last question. And that is 52.5, I believe. Yep. So that is how we work our order of operation questions. Hopefully that helped you today.